We would like to welcome you to our little talk, 3G Investigations, which is kind of interesting for us, was kind of interesting for us to research into this new thing nobody seems to know about, these networks nobody seems to know anything about, and yeah, we want to give you a little overview and some in-depth information that we got, and some things for the future we are going to talk about in later talks. Sometimes in the past, we dreamed of ubiquitous communication, and radio technologies should help us. But we had some difficulties with congestion control of the TCP protocol and the bursty nature of failures on radio Wi-Fi links. Our problem was, well, in the history, there were some problems, several problems with the communication. Maybe we all know the slow GPRS links, and the 3G networks like UMTS, HSDPA and things were told that they are the solution for all the problems we maybe have, we sure have. And after thinking, TCP with selective acknowledgements, the RC2018 was found and was created. And some billion euros later, when we got that idea of 3G UMTS networks, we got another problem. We got strange delays, obscure packet losses, and nobody seems to know why we got that. If anyone tried to use some of the UMTS services to date, might have experienced some of that things, strange delays. It's really, really slow. Packet losses everywhere, and well, nobody can tell you why. Nobody can tell you what happens. Nobody can tell you why it happens. And that's the point of our interest. We want to know why, what, and how we can shift around that. So, the contents of our little talk. Point 1, UMTS network details, some information about the network topologies, the BDP context, how it's built, how it works, from outside, when you look to it outside, from the outside, how quality of service within UMTS networks is made, and how charging of user data and that kind of interesting things like a lawful interception is done within UMTS and where it's done. Point 2 of our presentation is how we try to get into these networks and how the networks are realized. You may know that there are several network operators in Germany, like T-Mobile and Vodafone. And we did some basic measurements and had some information, some ideas about advanced measurements. And then in the last part of our presentation, we want to give you some information about how you maybe shift around the problems, how you could maybe in the future do some more sophisticated solutions than just opening a VPN or something. So my colleague will tell you something about UMTS network details.
Okay. Oh, it's still working. As Daniel told you, I will give you now a short introduction into the UMTS network topology. Go on. On the left side, you see, I hope you can see it. Oh, no gray color. On the left side, you see the UTRAN. It's a UMTS radio access network. Unlike cheaper radio technologies like WLAN, the radio access network within UMTS is divided into two major parts. There is first the node B, and second the radio network controller. The node B is more or less just the antenna on the top of each building, and the radio network controller does the more powerful things with the package. But both are more or less unimportant for us, but there's one interesting detail in normal UMTS. The acknowledgement on packets received from the cellular phone are generated by the RNC. This is a nice idea when you want to have a soft or softer or really, really soft handover. It's all possible with UMTS, but it's very slow. UMTS will take up about 80 milliseconds to detect a packet lost. And this will have a deep impact on the performance of our network later on. There's a new technology, it's called ahzf. This is really better. It will only take 2 milliseconds to detect a packet loss. This is possible because in this technology, the node B is far more intelligent and can react on packet loss directly, and not the RNC is used for this. The next important part of our network is the serving GPRS support node, or SGSN. It's more or less responsible for session setup and management, mobility management, subscriber database management, and charging of the radio network usage. Also not really important for us. Only the last thing will be interesting later on, the charging functions of UMTS. So keep this in mind. And the last thing on this slide is a GGSN or Gateway GPS support node. This is rather interesting because this is more or less the gateway from UMTS to the normal networks, like the internet or to your VPN, if you have a contract with your UMTS provider, or for the IP porno movie subsystem, or soccer subsystem, or just multimedia subsystem. There is something like this subsystem, at least in the UMTS standards, as you can see, top of the slide. If you will just go to Google and type in the 3GPP-TS.
May I interrupt? You can see, cannot see it
yes.
on the
beamer
projector.
is has some kind of problems.
The slides are available online, so later on you can, when you have a Google link. Okay,
there should be a reference to the UMTS standard. Just get the slides. Yes, the GGSN is responsible for connecting the UMTS network to other networks. It's responsible to give you an IP address, to do some network address translation, or for people who like mobile IP, it could be responsible for doing things like foreign agent. The really interesting things the GGSN is responsible for is user data screening and security. This sounds interesting. It's more or less today just a firewall. And it's also responsible for charging the bytes you send from UMTS to other networks or the bytes you receive from the internet. Next thing is the packet data protocol context. This is more or less a tunnel. It's between your mobile equipment and this GGSN, because you want to do roaming and move around, and nothing should interrupt your session. This is quite a nice thing for UMTS. It's aware of mobility and it's aware of quality of service. You can even have more than one of these contexts, but you have some problems with the design of the PDP context, which will be on the next slide. Also, there's no possibility for the mobile device to initiate a context modification. The mobile device can set this tunnel up or can take it down, but if it's set up, there's no possibility to change any of the details of this tunnel. And again, another tunnel is used, or some people just call it PPP, to do another session context between your mobile device and the GGSN. There's not really any kind of use for this, but provider like PPP, as you can see at home with your DSL, there's also, PPP over Ethernet, but there's no use for it, really. Okay, the PDP context, as I told you, is characterized by the network address. It can be an IP version 4 or version 6 address, or an IP version 6 prefix. This sounds interesting for us. Cisco also supports network behind mobile feature. There can you just add routing entries in the GGSN and have more than one IP address on your mobile device. As far as I know, no other vendor supports this feature today. You all may know from UMTS or GPRS these access point names. It's just the endpoint of a tunnel where you want to connect to. It's some kind of a DNS name for the GGSNs, because when you set up your session, you don't want to connect to a specific GGSN, but to a GGSN which can handle your connection with a special service or something else. Vodafone has, as far as I know, 2 access point names. The old one, wap.vodafone.de, or the newer one, web.vodafone.de. T-Mobile, I think they only have the internet.td1.de access point name, and last but not least, the QoS level is also characterizing the PDP context, and this is a bit problem, because it's nice to have quality of service in UMTS, but it's not really working as you might expect it. You have 4 classes of quality of service: the conversational class for really high priority data with guarantees. But as you can see, 80 milliseconds isn't really fast. And this is the best class in UMTS. There's a streaming class, a bit more delay. Then the last two classes have no guarantees, it's just priority. They are more or less for normal web browsing or background services like email, FTP, and so on. This would be nice to have, at least some of the classes, but your PDP context has only one quality of service indication. So when you want to have more than one quality of service, you might, when you do multimedia streaming also, it would be nice to send some packages or some frames of the streaming, the high priority, and all the not so important frames with a lower priority. And this would be very nice to have, but it's not possible with UMTS because you have only one context. You could have more than one context, but as far as I know, no vendor of mobile phone does this support today. Another thing is the quality of service is only supported within UMTS. There are no ways to indicate the quality of service level to the normal internet or other networks, because the UMTS will reclassify all packets who come in or go out with the quality of service level you have in your PDP context. Also, this means all diff-serve tags or type of service or class of service tags in your IP packets will be deleted. If you look at the standard, you will see a round trip time in UTRAN of about 120 milliseconds and in the core network of 20 seconds. This is really slow and will have a deep impact on the slow start phase of TCP. When you start downloading, it will be really, really slow, and it will take a long time for the TCP session to get to a higher speed. And when you lose some packets, it will also take a long time to get a retransmission of these packets. So most of the time, the UMTS won't give you any data because it's waiting for timeouts or something else. Okay, this to quality of service. Another interesting thing we found is charging within UMTS. Most vendors think it's not longer enough to only pay for using the service, or to have a flat rate, or to have the old local call and faraway call distinction. They want to have a sophisticated billing system and want to, yes, let you pay for more or less every bit you transmit. This means sooner or later you will have the possibility to send voice over IP over your UMTS telephone, but it will cost you a lot more than just sending an email or something else. So far, the theory of the vendors. There are a lot of possibilities to get to your money. But at the moment, the charging is limited to the PDP context. If you have one PDP context and you send 1 megabyte of data, you will have to pay for 1 megabyte of data. It's not important what kind of data you are sending. But this new concept is called IP flow analysis, and it will base on different the types of data. This can be, if you look into the standard, for example, URLs. Also Microsoft.com may be more expensive to view than ccc.de or so. Oh no, I don't think ccc.de would work. zip could be more expensive, port numbers could be more expensive. For example, using HTTPS could be more expensive than using HTTP. And another thing is the real IP flow analysis. When you think of peer-to-peer or internet games where you have a lot of open ports and a lot of different kind of data, you want to have some kind of aggregation of this data. So that you don't have more than 1,000 entries in the charging database, but only one. The amount of data is still a problem, and when you think of cheap providers like E+ or so, they already give you a flat rate for GPRS, and I think in the next days also for UMTS. This is not because they want to be nice to you, but they have a real problem with charging. But again, it's not really clear if it's in the future good for them to give you a flat rate, because they have to keep all your records anyway, because the law enforcement agencies of the European Union will force them to do so. So if they can keep your data anyway, they can also analyze your data and get more money from you for your transmissions. So conclusions for the part 1 of our lecture. The UMTS packet switch domain is far more complex than technologies you know, like VLAN or the upcoming WiMAX. The most interesting part for us is the GGSN, where packets can be filtered or charged or perhaps delayed. And with the upcoming IP multimedia subsystem or SACA subsystem, charging of individual IP flows will become of interest. I don't think in the next year to the soccer games in Germany, but perhaps in 2 or 3 years. And if they do so, we just want to have some fun with their doings and will analyze their doings today and have probably some fun with the hack value inside this IP flow analysis. So I'm ready with part 1, and I will give back to Daniel for the next part.
Yeah, the next part is get to know your network. We've got several devices for our research. First, these small HTC universal devices, which can handle UMTS quite well. And secondly, such a PCMCIA card, PC card from Vodafone. We paid for them. They did not give them for our researchers. And we had some plans to deal with E+ in Germany also, but they were not able to deliver us a card in time, which means 3 months. Okay, let's start with Vodafone, which is formerly known as D2 in Germany. When you all set up your tunnel to the GGSN, you're part of an internal private network in a 10.0.0.0/8 network, and no IPv6 is available. They do network address translation, and you normally have an external IP which changes from time to time, but normally it's the given IP here at the moment. There are many transparent application layer proxies which interfere with your data, like they transcode and resize and reshape, re-encode everything you see on screen. When you use that Vodafone card and use the software that comes with it, you, for example, you're seeing all pictures on websites in a really bad quality, and just when you reload several pictures or the pictures you want to see in better quality, you get a full detailed picture with full size, and then you are experiencing the real speed of UMTS, which is quite slow. My colleague told you about the slow start, which takes quite about 3 to 5 seconds, which is not enough for a 100 kilobyte image. So you're getting the image not in the high speed mode of your UMTS network. You're getting it really slow. In our measurements, we got over the 100 kilobyte per second, which we mostly arrive with cacheable data, for example, FTP or HTTP connections. So they are probably using transparent application layer proxies for this. And from time to time, you also get above that 100 kilobyte, but 100 kilobyte is known as the maximum speed you're getting when you're completely alone on such an access point, such an internet, such a point. On good links, so when you have full reception, full quality, your packet loss is up to 3%, which is not really good for TCP and not really good for the speed. As we told, 120 milliseconds for packet loss detection and resending is not included in this time, will cause very long delays. In our measurements, from 293 milliseconds to 494 milliseconds, which is some kind of which sounds faster than you might think, but there are some measure points that are above 2 seconds, above 4 seconds, which come very often. There are some hints, some things that point us to packet filtering and delaying, because on some access points we used some ports were closed to the outside world, and even some ports were hardly delayed, more or less. IP packets with the record route enabled are dropped. No packet forwarding between the user equipment, which we did not really expected that they will allow us to communicate between the devices. But, well, could be fun if they would. DNS and TCP seems to have slightly higher priority. You can see it when just pinging UDP port 53, you get ping times from about 50 to 80 milliseconds when there's no packet loss. And pinging another UDP port, let's say 666, you get ping times from the very long delays above I mentioned earlier. As I told, the cacheable data seems to perform best but the slow start is some point. Well, you have to wait before the data flows quite in high speed. 100 kilobyte is okay when you download a larger file, like 10 megabyte or up, but you need to wait until the file is cached and the TCP slow start is getting in flow, so you can receive the 100 kilobyte. Well, only if you're alone on that access point. The iPerf test tool doesn't perform well, which we think is caused by the transparent proxies that might detect that test or might not handle that and just delaying what they can. We know from Vodafone that they are planning to implement several filters and delaying rules, like for voice over IP, commonly used voice over IP ports from July 2007 on. As we think they might test it at the moment, but mostly no filtering or something is taking place. On some access points I had some problems to access several ports. On other access points I did not. Depends where you are, depends what the software version, which we don't know, is on that access point. By mostly I think by ports and content. Since they are using transparent proxies and they are planning to charge by content, they will most likely filter on both. The port filtering is easy, the content filtering takes much more CPU performance, but you can think of both. Okay, we also tested the T-Mobile, formerly known as D1 in Germany, which has a very, very bad coverage in our places where we tested, which just means you're constantly roaming between GPRS and UMTS, which is handled by the network quite well. But with that come some packet losses and huge delays, up to 2 to 4 seconds, which just means every time your device is handing over to UMTS or GPRS, you have to wait for the resending of the packets that are lost in that part. We had some, I had some handovers where no packet were lost, but the delays are really, really hard to ignore when you just download a web page or doing some streaming. T-Mobile seems to use official IP address space, which just means you get a real IPv6 address, which is packet filtered anyways. They have several packet filters at the moment, and you can enable a transparent HTTP proxy, which we tested, to resize and re-encode, recompress your web pages. It does work the same like the Vodafone version of the transparent HTTP proxy, but you can disable it from a T-Mobile service page, and you cannot switch between those both without reloading a complete page. In the Vodafone solution, you can just reload one image, don't have to reload a complete page. The delays are similar to the Vodafone solution. When you have a good reception, when you found a place where you have good reception, which means 200 milliseconds up to 600 milliseconds, And because of the bad coverage, we don't think that the measurements are representative for all networks of T-Mobile. I think they are building the network at the moment because I had several events where the coverage the reception just got better from day to day at the same place. In one place I had 10% reception, which means no reception, and the other day it was 90%. It seems that they just set up a base station directly in the neighborhood. As I mentioned, we did not get an E+ account at the moment. As we know, they have a GPRS flat rate and they have UMTS flat rate or planning, but
actually they have a UMTS flat rate already.
Yeah.
And they have it running for like 3 months now.
Okay. We can wait for a audio angel. Behave.
Well, E+ has a UMTS flat rate for 3 months now.
Yeah, we hope that somebody in the audience could tell something about it.
And it works similar to the Vodafone one, except that I think they don't use any proxying to rescale images or any sort of that stuff.
Sounds good.
You get a private address and you're netted. What works perfectly fine is that if you run a NAT on your local notebook, you can actually forward data from other laptops through the GPRS or UMTS.
Oh.
So that's
cool.
pretty nice. That's what I did yesterday when the Wi-Fi didn't work here.
Okay.
And you do switch in between GPRS and UMTS if you don't have UMTS coverage, but that actually works quite well.
Better?
Yeah, you actually don't really notice a big difference. You just see the difference in speed between UMTS and GPRS.
Okay.
But the switching goes pretty fast.
Can you tell anything about packet losses or?
Well, with GPRS you have the usual 200 milliseconds to 300 milliseconds delay, which is usual for GPRS.
Yeah, of course.
You've always had that. And with UMTS, since I hardly have UMTS coverage where I live, I didn't really test that a lot, but I tested it yesterday here, and it works okay for SSH. So
okay.
You actually can use SSH, which is all I need. So
with 500 millisecond delay between each.
Well, no, you actually have a decent rate.
Okay.
So.
Cool. And the packet loss?
I didn't test that really, and
okay.
I didn't do any big downloads, so can't
okay.
say anything about that.
Yeah.
I can test that and give you feedback to your email address.
Cool. Thank you. We will put that information inside the talk slides, and we made it available as soon as we got the information here. So you can download and access it after the talk. So we go on. What did we test? Basic measurements, all the standard tools, of course. Ping, -R, traceroute, iperf, echoping, nmap. But we were looking for a more integrated tool which could measure the latencies and routing of packets using different ports and different protocols and slightly modified packets, which just leads to self-made solution, because we wanted to use it on the very mobile devices. And we created a tool set which is a server and a client. The client is on the mobile device, which creates packets and measures the time. And at the moment, it's a very simple client. It does work, but there are a lot of things to do. The client application is coded in C# based on the .NET Compact framework, which is quite good for the mobile devices. And the server is made in Java at the moment and will be replaced by a C# version. We did not have the time to rewrite it in time, because we're running into some issues with the raw IP reception and generation in Java that are easier to deal with in the C# network stack. The server part of the software just provides echo functionalities, which means you're connecting to the server, telling him what port you want to connect to, and he opens the port and you send data and he replies on that port with the data you send. There are some peering functionalities planned to implement into the server, which is quite easy to implement. We did not have the time to this talk to communicate between the devices through the server, especially when the devices are behind a net. One issue with the compact framework at the moment is that there's no row IP support. So we had to p-invoke, which just means we have to use device specific code, which as far as I know will be solved. That problem will be solved in the future. The source code is also available, of the tools is also available, where you can get the slides. The addresses are at the last line. Okay, so now I will hand over to my colleague when it comes to the last part of the talk, which is adapt your traffic patterns.
Okay, as you have heard, today the UMTS network is still a bit boring. It's working, it's not working very fast, but you're getting your data. There are some services or ports or whatever that you cannot access. The first solution, or the poor man's solution, would be use a VPN and it's good. It will work. It will increase your delay and yeah, your bits per second will decrease, but it will just work. So we thought, no, UMTS is still so boring, we have to find better solutions to have some fun. The first thing, we set up the design rule. We don't want to use any kind of VPN or IP tunnel for the main data flow. This means most of the packets should be sent directly. It's only allowed to send some packages via VPN or inside ICMP packages or something else. Because UMTS is really slow enough. And very, very easy example. If you imagine there is a network A and a network B, and there's perhaps some very stupid packet filter, or GGSN, I don't know. It's up to your imagination. And you want to connect to a specific port. You might think of zip or so, I don't know. The direct way will be prohibited by the service provider, but in the other way around there will be no limitation. And the normal scenario in UMTS is on the one network you have device under your control, and in the other network there's also a device under your control. So you can do really a lot of things. So we thought, yes, let's first solve this problem with the TCP connections. The first solution was the minimal routing approach. We call it so. That's no really normal calling for this. We want just send the main data, TCP data, the direct way, but the TCP SYN package which is normally dropped in the GGSN or packet filter, should be sent via a VPN. So we want to keep the overhead as small as possible. At the moment, because we have some troubles with the Windows Mobile 5, we just implemented a Linux version just to show you, yes, this could work and this is working. Just use these few lines of code. Set up your normal IP tunnel, for example, OpenVPN. Use IP route 2 to register a new routing table. It's just echo. And then use NetFilter to do firewall marking, especially marking the package you want to send through the tunnel. This is nice because even when you do direct communication between the two devices, you don't run into trouble with IP addresses, because when you normally would send through the tunnel, the IP address would change to the IP address of the tunnel. But with this solution, it won't. It's just, yes, very trivial. You can do it, just copy-paste and do it at home. But keep in mind, this solution might not always be optimal if you have a provider or a home network with return path filtering enabled. Okay, there is nearly no network with return path filtering today, but it might. There's another way to do the job. It's where we call minimal modification. It's dedicated to Ambendus, somewhere in this room. It's his idea to do quite the same job as I did. His idea was not to send it in another way, but just to solve the problem directly. The packet is filtered because the TCP SYN is set. So just you could remove it, but then you might run into troubles with some filters who to do stateful packet filtering or something else, or who just look at packages and see, oh no, TCP option set, this might be a strange packet and I will drop it. So use just the ACK bit, set additional the ACK bit, and then it looks like an answer of another station for TCP SYN packet. Normally, as far as we know, even the Vodafone GGSN accepts this packet. On both sides, you use the NetFilter connection tracking to do your recreation of the SYN bit or removing of the ACK bit. Because when you get a package and there is a SYN ACK bit set, but connection tracking says, I don't know this connection, then you know, oh, this could perhaps be a packet of mine, and I will just remove the ACK bit again and send it again to me. And oh, yes, cool. Now we have a connection setup request. Let's set up this TCP session. The hard stuff is done inside two Perl libraries. It's called netpacket and IP tables. There's just some queue management and changing of packets, recalculating the checksum of the IP packet and TCP, I think, and then you just send the packet out again. The code will also be available on the normal web link. So I give back to Daniel for the overall conclusions.
Hello? Maybe we... Okay, yeah, now it's working. So, what did we learn about UMTS? UMTS is a great technology for accounting, charging, and with HSDPA and HSUPA, which is the uplink version of the HSDPA. Perhaps is even good using it. If there are any IP filter delays and special charging in the future, we want to find ways to deal with them today before they are set up, probably before they are set up, and they will come. This could lead to an automatic creation of traffic delay maps and adapting our packet flow by using a minimal modified packet. And the big hammer solutions like VPNs are not always the best approach, and smarter techniques, smarter technologies should be preferred. So now we have 5 minutes from my clock for some questions. You can email us or subscribe to a mailing list.
Yeah, you mentioned that DNS seems to have higher priority. Did you try setting up an NSTX proxy? You know, where you proxy your packets through DNS text messages?
No, we did not test it.
Yeah, you should try that.